Hey, do you want to stay for an tonic? You sure? It's fantastic. It's all right.
household level data and then just runs it out for the shots.
second. Well, welcome everyone for another great lecture of 4 to 6. Hope you didn't miss me too much, but it's great to be back. I'm aware that some of you had another lecture that was unplanned today, so you might be a bit tired. So I'm going to try to make it as entertaining as possible. As always, just to remind you, if you have any question throughout, just feel free to interrupt, raise your hand, or do whatever you want. Just ask a question. For the seminars on Wednesday, there are 2 papers that you need to read. That's all. There is no problem set or anything like that. So please make sure that you read the papers before you come in on Wednesday. Before I start, any questions that you might have, I sent to the econ student quite a lot of information about the extended essays, but if there is any other question that you might have, some of you already emailed me. I try to reply to everyone. I think I did. If not, unless you emailed me in the last day or so, please email me again because I might have missed your email. I try to reply to everyone. And if you still have, you want to see me during my office hours to discuss anything around the assignment, please let me know. Right. Any questions? What's sorry? It's just for the econ students, yeah. Yes. Yeah, so I said a few weeks ago that there's going to be a meeting, but I think that, so basically I sent you guys and after Moodle a very detailed instruction. I can arrange a meeting, but I didn't think that it's kind of needed to bring everyone in. But again, if there is a need, I'm really happy to meet and arrange one. Alternatively, you can just feel free to come to my office hours and I'm happy to chat with you individually. I just didn't see the point of dragging you for an hour for something that I think is quite straightforward. Yeah. Any other question? Okay. All right. So let me kind of tell you where today's lecture is kind of positioned. So hopefully in the last 2 weeks or so, you start talking about, start investigating how you can estimate the marginal willingness to pay for environmental commodities, essentially demand functions. And what you covered either last week or the week before, I don't remember, is one kind of way to do that with this stated preference, which you essentially kind of ask people about, how much they're willing to pay for whatever environmental commodity you are interested in. There are lots of positive aspects for using stated preference. It's extremely flexible. You can extract kind of really important values that you might not will be able to extract with other methods, but also there are some issues involved. One of the obvious criticism is that, look, you ask someone to give you a value of something, do you know if they reveal the true value, okay? And it's also hard, to come up with the values for certain things. So it's obviously super useful, but sometimes it's a bit limited. And today we're gonna look at an alternative method to try to put a value on environmental commodities. Specifically, what we're gonna do, we're gonna follow people. We're not actually gonna follow people, right? But we're gonna try to follow people actual behavior in real markets, okay? Not hypothetical scenarios. We're actually gonna follow people, see how they behave in real markets, in related markets to the thing that we are interested in, okay? The kind of big group of methods that kind of, help us to do so is what we call revealed preference methods. There are a few of them. We today gonna specifically talk about the hedonic price method, okay? So that's what we're gonna try to do today. It's an extremely powerful method to use to get values. And I will tell you, I'll try to do my best to kind of show you how you can use it very well. And I think potentially as important, tell you what you don't want to do. Okay, and I'll try to do that as well. Okay. Right, so reveal preferences more broadly based on the assumption that we can infer preferences for environmental goods by analyzing people's actual behavior in real related markets. And again, the strength here is that it's based on real behavior, actual choices that people make. People actually put money on the table. Okay, it's not just, oh yeah, this is the value that we put on something. No, they actually put the money on the table, right? So that's kind of the big strength, and this is why I personally like working on that. The hedonic price method in particular, it's a very helpful tool, and the intuition here is quite straightforward. The intuition here is that there are a number of goods, mainly we're going to talk about the housing market, that have multiple characteristics. For example, when we think about houses, different number of rooms, different neighborhoods, lots of different stuff. And the point here is that we can potentially use the overall price to infer the price of each characteristic. And one of the characteristics might be, because this is our interest, some environmental good that we are interested in, or environmental bad. Specifically today, we're going to talk a lot about air pollution. Sorry in advance. Not all about air pollution, but most of the examples are going to be around air pollution, because you stuck with me and this is what I'm interested in. Right? That's the truth. But I'm going to do one that is not about air pollution, I promise. All right? Just to diversify a bit. But that's kind of the main intuition. So there is a house, for example, is a bundle of different goods. We're going to try to find one of the goods isolated and think how the price movement can tell us something about individual and how they value the environment. Okay? Again, just to kind of give you a slight intuition on how things are actually going to work here. The first thing that we probably want to ask ourselves is what actually determines the price of a land, okay? And it is the value of the stream of services that the land can be expected to provide in the future, discounted back to the future. Now, the problem here is with the word expected, because expectations are unobservable in the data. So therefore, we can differentiate between two different prices. The first one is what we call the rental price of land. Here, expectation take little or no role. Why? Because this is just the services that the land provides today. So if you think about agricultural land, for example, is all the yields that we can get from the piece of land that we have. The other one is the asset price of land, which includes today's value and all future expectation of future value. So it's not just the stream of value that we will get, let's say, in the next year or so, it's also what we're going to get from the land in the long run. Okay? So these are two kind of things that we can distinguish between two different kind of prices of land, right? So let's go back to the point about agricultural land. The rental price of land is the expected value of the output from the land, less the cost of labor, seeds, and other non-land inputs necessarily for output. If you think about air quality, for example, poor air quality land results in lower prices. Why? Because higher level of air pollution has been shown to reduce yields. Okay, so therefore, we expect the rental prices to go down. Okay, if we know that a piece of land that we have for agriculture can provide us less revenue, right, less yield, therefore it's worth less money. That's the point here. Okay, this is just as an example. Now, the main question that we're going to have here is when we can presume that, for example, here, air pollution is capitalized into land value. Put it another way, when can we use land value to value an environmental amenity? Okay? And we're going to consider two cases here. Well, more than that, but we're going to consider two different settings. One is agricultural setting, and the other one is urban setting. Okay? In general, what I'm going to do in this lecture, I'm going to start with the theory. It might look a bit boring, but it's absolutely crucial to understand the theory in order to do good empirical work. Trust me on this one. And I'm going to show you what I mean by that today in the lecture and also in the seminar on Wednesday. Okay, because if you don't really understand the theory or where it's coming from, it's going to be hard to get the empirics right. And I'm talking, this is what I'm gonna explain today and on Wednesday. It's really the frontier of research, okay? So I hope that I'm not gonna go too much off slides here, but I'll try to kind of make the point. So I know it might be not boring, definitely not boring. Nothing that we do here is boring, but it's might gonna be a bit slower in the beginning, but then it will get more exciting, all right? So bear with me, it's important, all right, to understand that. All right, so let's go with agricultural land. Consider two agricultural regions, one dirty and one clean. And here, agricultural productivity is lower in the dirty region, as I explained before, the reasons why. And this is really clearly reflected in the prices. The question that we have, how much are landowner in the dirty region willing to pay to clean up pollution in the dirty region? If that is equal to the difference in land prices, therefore, if this is the case, we have an easy measure of willingness to pay for clean air, right? But let's find out whether that's actually the case or not. It turns out, and that's kind of the key message I'm going to show you today, that it really depends on the market structure. I'm going to show you what I mean by that. What depends on the market structure? Whether we can actually infer something about the willingness to pay, okay, from this price differential. Right? But let me show you what I mean by that. That's one of the first key messages that I want to communicate today during this kind of theory section. All right? So let's consider two cases. Again, within agricultural land. The first case is when agricultural market is local. Okay? So here, the price of agricultural output is determined locally, and cleaning up pollution increase the supply, right, of the agriculture yield and lower the price of the crop for all farmers, right? Because prices are determined locally in the market, right? The land prices drop in the clean area and rise in the dirty area, right? Therefore, the difference in land prices does not fully capture the value of clean area, right? Does that make sense? So basically what's going on here, if we have a market structure, if we have a local market, and there is a dirty area and there is a clean area, we clean the dirty area, right? So the price of the land goes up, but that's not going to give us a good reflection of the marginal willingness to pay, Why? Because it's also going to affect the price in the market for the agricultural goods. So the people in the control group, if you want to use kind of, empirical language, also going to be treated because they're going to get, right, the prices going to go down. So if they are a consumer, they are going to benefit for that. If they are a producer, the price that they can sell will go down. Yes? That's the point, right? So yes, because basically what's going to happen is going to be an increased supply, right, of agriculture. That's exactly the point. From the producer side in the clean area, right? So price is going to go down because the yields in what used to be dirty area are going to go up. Price is going to go down, so the farmers in the cleaner area originally will suffer from lower revenue because price is going to go down. Exactly that, right? So in this is the case, we don't have this clean setting, right? Dirty versus clean. One area is being clean, everything else constant. Everything else is not constant because of one thing is what you said. You can think about the consumers there in this area, for example, or in other areas, because prices are set, locally here, they're going to benefit from that, right? Because prices are lower now. But in any way, there are more than one channel. We just want something very, very clean. We're not going to get that in this setting. Okay? Yes. Yeah, everything that we assume today is perfect. Second scenario is when we have the world agricultural market, okay? Now, suppose that prices are set globally, which is not necessarily a bad, approximation of what happened in many cases, right? Depends where you are. I mean, when I buy my fruit and veg in the supermarket, very few of them are actually manufactured here in the United Kingdom, unfortunately. Or fortunately, I don't know. We can talk about it another time. But what happened here? The cleanup doesn't affect the price of the product, right? Because the price of the product determined at the global market. I mean, you might gonna tell me, look, there is an increased supply, right? So it might have a tiny effect, right? Because prices go up. But it's not, I don't think it's fair to assume that it's sufficient to change global prices, right? Here, the change in land value is actually a good measure for the willingness to pay. Because what we get here is just the effect for run channel that we're interested in. Okay? So that's what's going on here. Now, any questions about that? Yes, sorry. Let's do the housing stuff, okay? We're going to do urban right now, and if you have a question on that, follow up, all right? But that's exactly what we're doing. So let's talk about land for housing, okay? Let's do that. Urban land, okay? So now the land is used for housing. Here land represents the utility of mainly of location, right? You want to live in London because all of the amenities, yes.
Quick terminology question. In the first case, would that be then considered a pecuniary externality? That's one term that calls that.
In this setting, why is that going to be? I think it's. Let me get back to you on this one. I don't really see the obvious channel here. Right. So what we have here is we have land for housing. Again, there is a dirty area and a clean area, and we're going to assume that all individuals are the same. Just going to make our life very easy. Okay, just to kind of not worry about some sorting models and things like that. All right. Question here, does the lower value of land in the dirty area reflect the value of air pollution? Let's consider, again, two cases, okay? I think that's going to answer your question here. So we consider an open city with free movement between cities. So basically what happened here, people can just, free to move between cities. You don't have to live in London, you can go and live in Birmingham if you want, okay? Or wherever you want, okay? Everyone is the same. So basically what's going to happen here is that everyone going to have the same level of utility and income because this is the assumption that we make, right? If that's not the case, they're just going to move and beat up prices, right? So they're just going to decide on where they want to live. But again, because everyone is the same, so everyone has the same level of utility. To compensate for dirty air, price of dirty region must be lower, right? Otherwise, I wouldn't live here, I wouldn't live somewhere else. That's the point, okay? What happens if we clean up air in one city, okay? So the value of the land in the dirty area rises to compensate for cleaner air, right? So now it's not as dirty, so the price of the land is going to go up because people don't want to live in dirtier area of town. That's the main point here. However, the utility of individual will remain the same. We're not increasing the utility of individual. There might going to be an epsilon increase, but basically the utility of individual will stay the same. Because we're not talking about one city, we're talking about a multi-city equilibrium, we're talking about a lot of cities. So even if there is some increase, by utility it's going to be divided by so many people such that there is no significant increase in utility. This is how we need to think about that. In contrast to what I'm going to show you in the next scenario. Here, the increase in land value is an exact measure of the value, or near exact measure of value of air quality. Okay, so this is kind of related to the point of what we did before in an urban setting when we care about housing, when we care about location. Okay. The second scenario is when we have a closed city. Okay, so now there is no mobility between cities. It's hard to think about scenarios there is absolutely no mobility. So another way to think about it is that there is no perfect mobility between cities. Okay, there is some restriction, and you can think about some, or for example, you can't move between countries. You can think about it in that sense. But certainly there are countries that there is some limited ability to move around. Then the utility within every city is identical across all individuals. So within a city, right, but not between cities. Within a city, the utility is going to be the same. The difference in property value reflects the value of air quality. Now we clean the air. In the dirty area, what happens? So here we have two things that happen. First thing that happens is the land price of the dirty area of the city going to go up, right? Does this reflect the true value? The answer is no. Why? Because the utility also going to change. Why is that? Because now we have a relatively smaller area, just one city. We had two regions, right? We have this equilibrium now that everyone now will have higher level of utility. Okay, so again, we don't have one channel anymore. We have two channels. And that kind of make a big issue for us. So we have the observed property value increase and the unobserved utility increase. So the main difference between the two, essentially, if you want to think about it, is that the increase in utility from one region now is just divided by the population of two regions, compared to the case that we had before that is divided by much more than that, and therefore there is no meaningful change in utility. Okay? And that's kind of the analog, I think, to the agricultural land. Okay, so it's almost like, you know, if equilibrium in here, utility is determined locally or globally, or multi-city equilibrium. That's the point. In urban terms, in urban economics terms. Okay. There is also some general equilibrium effect, but we don't talk about it anyway, so we're not going to talk about it today as well. All right. So this is kind of the point. Basically, what I'm trying to say here is that you need to think about the market structure, okay? So when you try to do an hedonic, and I'm going to give you an example later on today when we talk about empirical analysis, you try to think about your own setting and how things work, okay? And it might change, depends on your setting, geographically or exactly what you're interested in, all right? So always kind of come back to that. Can I actually use a hedonic here? Does it make sense? Does it actually reflect what I'm trying to get from a theoretical perspective, right? Because I'm trying to create a demand function. I'm trying to get the willingness to pay, the marginal willingness to pay. Okay? Or not, right? So this is kind of the very, very basic first lesson, all right? Let's talk about how these things actually work in practice, okay? How we can actually measure demand, okay? So as I said before, the intuition here is that in the real world, we often observe bundle of goods that are assigned a single price, and houses is a great example for that. So I recently actually moved house in Reading Week. I was moving my family from one house to another, and then we've been looking for a new, it's not a house, it's a flat. We still live in London, and I'm still working here. But, you know, it was kind of like a very interesting experience for me. I mean, we had a house before, flat before, but you know, it's kind of interesting to see what we care about when we are looking for flat. And some of the things is like, you know, I also have a wife that she cares about some different things than what I care about. But most people, I think, cares about, you know, things like the number of bedrooms, right? I have 2 kids. I want to be able to, you know, to give them some freedom and some, you know, somewhere to sleep in. I think it's going to be nice. The number of bathrooms, that's also important, especially when you have girls, apparently. Kitchen, not eating in the living room. That's something that really kind of changed our household. It's really nice. And schools, for example, as well, right? All these things are very, very, very important, right? So, and you see how, I mean, some of you are very young, some of you are slightly older. You will see when you're going to go and well, you probably already made some decision on where to live, how you take this, all these different features into account. But obviously you might care about some environmental commodities as well, things like air quality. I don't know how many of you check air quality before you make a decision on where to purchase or rent. I totally did, but I'm definitely an outlier here. But you know what? It might be bundled with something else. So, for example, you might not want to live next to a major road because it's very noisy. Okay, so you might gonna get a signal about air pollution, especially traffic-related pollution, if you are going to view a flat, a very nice flat, it's in, but it's on a main road, and you hear the noise, and then you start thinking, oh, okay, the noise maybe we can deal with, but what about the pollution coming from the, from the road and things like that, right? And that might have, an impact. Well, not might, will certainly have an impact on the house value. Okay. So what we're going to try to do is to try to think about. Imagine the following: two identical properties. Okay, they're identical in every way except one. Right. So same number of bedrooms, same beautiful original features, high ceiling, fireplace. What else do you like in houses? I don't know. What do you like in houses? Space. Number one, actually. Yeah. What else? What do you like in houses? Sorry? A balcony, an outside space. An outside space. All these different things. So we're going to try to isolate one thing today, for example, which is going to be air pollution. You guessed right. Okay? Holding everything else constant, okay? And we're gonna try to infer between these two properties, between the difference in prices of these two properties, about how much people really care about air pollution. What is their marginal willingness to pay to reduce air pollution by X amount? Okay? And it seems like quite easy thing to do, right? Because, by the way, in the UK, all property transaction is freely available via the land registry website. You can get that, okay? But I'm going to show you how actually in terms of what you actually want to get, the value that you actually want to get, that is actually slightly more complicated than what you think, okay? Again, the good news here, is that data is widely available, okay? So let's kind of start thinking about what's going on behind the scene and how prices are actually being set in the market, okay? That's, again, I guess, lesson number 2 today, okay? So, again, the goal here is to observe houses that are identical in every characteristics but one, and then use the difference in house prices to infer the value of that characteristic. Today is going to be mainly mainly air pollution. And in doing that, there are two big questions. One, how is the price of the house set in the market? There are two sides to the housing market. People tend to forget that. I'm going to remind you that today and on Wednesday. That's crucial. I'm going to show you why in an empirical paper of one of my papers. And two, how can we infer consumer willingness to pay for changes in their characteristics, a demand curve for pollution? And I'm going to show you how problematic that is as well, and what we can and cannot infer from hedonic studies. Okay? So let's kind of do that. Lots of it, where are we now? Okay, right. So we're going to start the basic setup here. The way that I'm going to do it is going to be a bit kind of going backwards. So I'm going to assume that we already have prices, that prices are already kind of determined in the market, but we're actually going to try to create this price function. Okay, so we can kind of almost reverse engineering here. But this is how I think how it's going to work for the best. All right. All right, so this is the basic setup. A single homogeneous area, such as a city or part of a city, which can be considered a single market for houses. Each house can be characterized by a single characteristic, Z, air pollution. Again, you can change that. It doesn't have to be Z. And what we want to know is PZ, okay? So how the price of air pollution kind of vary across. PZ here results from the interaction of supply and demand. That's what I was saying before, and we will need to account for this directly in our analysis. Let's assume that the market is competitive, going back to your point before. So producers and suppliers take PZ as given. Again, we just walking backwards here. Okay, I'm going to show you exactly at the end here how PZ is being determined in the market. Okay. All right. So let's start with the first side of the market, the consumer. Moi. Okay, this is what I was until a few weeks ago, right? We have in our household a utility function, U, that I keep reminding my wife what it is. And we also have an income, which I also keep reminding my wife what it is. X is basket of other goods, all the other things that we need to pay for. Z is air quality, which I care very deeply about. And the standard maximization problem can be said in the following way. We maximize our utility, and what we care about is basically air quality. What we care as a household is about the air quality and also all the other things that we have to buy, the Netflix subscription, the food, etc., etc., etc. Okay? And we have a very strong budget constraint, right? So we have an income, we can't spend more than our income, strictly, roughly speaking, if we don't want to get into too much trouble. So that's going to be X plus P times Z, right? So this Z here, we need to think about what is the price of that as well, all right? Okay, so another way to kind of think about it, we want to restate this problem so that we can get the trade-off between Z and wealth, okay, or income. But it's better to think about it in terms of wealth, specifically when we talk about houses. How do we do this? Right, so let's consider expressing the problem in a different way, slightly different way. We're going to fix utility at some U star and focus on X given alternative value of air pollution or air quality, Z, okay? We can transform this problem in terms of wealth and pollution. So we're going to use this theta here, which we're going to define as Y minus X, so the income minus all the other goods that we consume. And that's basically going to give me the money available for house with a certain level of Z. Another way to think about what I'm trying to do here, I guess, is just basically what we're trying to do. We're trying to do some kind of an indifference curve, okay, for housing almost, right? Because we're going to keep utility constant. I'm going to show that on a figure in just a second. We're going to keep utility constant, and we're just going to have prices, right, and Z, environmental quality, on the axis. And we're going to have an indifference curve maps, okay? You're going to call it called something else, but that's going to give me the relationship between these two things. Holding along the indifference, along each one of these indifference curves, utility constant. That's what I'm trying to do here, essentially, okay? So we're going to call it the bid function, okay? And the bid function here going to be this theta that I'm just basically defined here before, right? Again, we're going to keep utility constant throughout, okay? So given value of Z, Y, and U, that's theta here determine how much money is available for the house. It represents the amount of money the consumer may bid for the house with characteristic Z to keep their utility constant, okay? This is how it's going to look like, all right? So again, we're going to assume that this PZ here, this guy here, is given. It's not. This is exactly what we're trying to get, but for now we assume this is given. And what we have is exactly the same kind of space that I mentioned before. We have quality and money here, right? And prices. And basically, we have different kind of what we call indifference curve, but we're just going to call that guy in here the bid functions, okay? That each bid function gives me the same level of utility, right? And if I want to get more utility as a consumer, I need to go down this way, okay? So the difference, one second. The difference between this guy here and this guy in here is that here you have higher utility. Well, why is that? Because at the given level of Z, the consumer have more money for X, right? So in here, right, I have more money for X compared to this guy here. Yes?
Higher up in the graph is
The more you pay for the property, yes. Absolutely. Okay? So so another way to think about it, if that's kind of easier, is to think that as a consumer, I kind of want to pay more, I want to pay less, right? And therefore, I have money for other stuff. The Netflix subscription, all the other stuff. I'm not working for Netflix. I don't know why I keep bringing Netflix up. Don't know. Sorry about that. All right? So this is kind of one side of the market. We're going to end up, okay, where we're going to end up, the consumer will choose a level of Z that maximizes their utility based on what they can afford and what they can do, okay? This is the point at which the bid function is tangent to PZ. So think about it, they have more bid function. with different level of utilities that I didn't kind of put here. But they're going to end up here because this is the best place for them. This is the highest utility that they can get given the house prices. Okay? So at this point in here, they just tangent to each other. Okay? This point here, this blue point here. Okay, this is what we call the choice point. This is one side of the market. Again, people forget there are two sides to the market. So this is the consumer, right? I also had another property that I need to sell. So I'm the producer. Not exactly that, but let's go to the other side of the market, the seller, right? The producer. Let's look what's going on here. Sorry about that. So here, this is the other side of the market, right? So they trying to sell homes. The key point here is that there is heterogeneity among producers. You can think about that as like selling of new homes, okay? That is, some are very good at making certain types of houses, while others specialize in other segments of the housing market. They have different costs, right? So the point is that there is variation in costs among producers, or you can think about it, they have different costs in achieving permits to do certain things. That's another way to think about that. Let's say for this example, is that the difference is, as I said now, the ability is to get building permits in area with varying air quality, okay? So, single producer cost of building a single house. What do we have here? It's kind of, it's I guess, simpler than the consumer side. We have R, which is the input price. We have a cost function, which depends on two things, okay? C here. Depends on the input price, but it also depends on the air quality, okay? Because let's say we need different kind of licensing. Depends on the air quality in the area, okay? By the way, not out of the question, this kind of stuff, right? Let's say that if we need to build next to a major road, we might need to do some other costly things in order to be able to build something there, okay? Because of legislation or something like that. Or even because of market demand. Okay, so that's what we have. Okay, we have phi here. This is the price the firm offered, because obviously the firm trying to sell. And what's the profit going to be? Well, it's just going to be the price minus the cost, right? So we can rewrite it in the following way. This phi here basically going to tell me the price necessary to obtain a certain level of profit given a certain level of environmental condition, okay? And that's what we call the offer function. It's a bit confusing because actually you think about the offer, when you make an offer on a house, you think about it on the other side, but it's how they call it in urban economics, so I'm going to continue with that, all right? So this is called the offer function, which is the price at which the producer will offer a house to obtain a profit, a certain profit given R and Z, given the input and the environmental good, okay? So what we're going to do here, essentially, we're going to show you the other side of the market on the same figure that I showed you before. And what we have here is we have this, by the way, sorry, I forgot, I'm just going to go here. Anyone know why the shape of this curve look like that? Of the utility? Yeah. Yeah, it's diminishing return to, exactly, right? So it's diminishing return to air quality. One, you have very bad air quality. For example, you're willing to pay much more to an improvement. Once it becomes much, much better, you're probably willing to pay less. Anyway, let's go to the producer. I forgot to mention that. So here what we have, going back to your point before, now basically we want higher profit. So along these kind of curves here, we have different level of profits, right? So this is profit associated with this curve here. And this is, higher profit. So because they want to sell for more money, right? So they're going to try to go to the highest possible offer function that they can, and they're going to end up in this blue point in here, okay? Which is basically the price that it's going to be sold in the market, okay? All right, so what do we have here? We have everything that we need, right? Because basically now I show you the two sides of the market. I show you the supply side and the demand side, right? And now we can basically form this PZ here. Why? because basically what we see here is that this PZ basically is formed by these two sides basically agree on a cell. Right? This is how we actually trace this PZ. Okay? Every point along the hedonic price function corresponds to a tangency between the bid of some consumer and the offer of some producer. This language here is important, some and some. I'm going to come back to that later. Okay? That's going to be important to our interpretation of the marginal willingness to pay. What kind of marginal willingness to pay we actually get from here. Okay? So here we see that the market equilibrium, basically PZ, is constructed. How? By the tangency between offer and bid functions that we have in our economy, right? So basically when the producer and the consumer kind of agree, okay? And this is actually what we observe in the data. The only thing that we observe in the data is when they actually agree on something. We don't see anything else. Kind of. Okay, I'm going to talk about a paper that by the way, I just added a few slides to the lecture slides, maybe 10 minutes before the lecture today, because it's a paper that I really like by my co-author. It's really new, it's not even published yet. But in general, we just see the transaction data. Okay, they can see something else as well, which hopefully we have time to cover. Okay? So this is how we kind of backed up this PZ, which is what we want. Okay? In a way. It's not exactly what we want, but it's what we want. Yes?
When does the supplier care about the air quality of the houses they build?
Sorry a second. Oh, why do they care about because I said, for example, that it might be associated with different costs. This is the point, for example, if you build next to, just give you an example, right? So let's say that you build next to a major road, you might be required to install certain type of walls or certain types of windows or things like that, or even to get a license might be going to be more costly. Wouldn't that be associated into the price? Oh, no, that's just an extra cost. And then the price you can set. Yeah. All right. So now, and that's kind of the key here, how can we go from this market equilibrium to inferring consumer willingness to pay for change in air quality? Okay, in order to make rational decision about policy, we need to have this information. And if you want to go back, what are we trying to do here? Remember the marginal damage, the marginal abatement curve? We're trying to get a marginal damage. Okay, that's what we're trying to do here. Okay. The question is whether we can just measure the slope that I just showed you today, which is basically using the data from the land registry at different point, and this information is basically what we need. Okay. Because, so that's the question. The answer is no, because this will only tell us how the market price changes rather than the underlying willingness to pay of every individual in our economy. So let me kind of, I don't know if it's the next slide or not. 2 more slides, okay. But it's kind of build up to that. All right, building up to that, right. So we really want to know how a particular individual, this is crucial. I know I've been talking for what? 45 minutes now. After this point in here, we're going to take a break. But listen to that, because this is really important and many people don't get that. All right? What we really want to know from the marginal damage perspective, think about how we set up the tax, all these kind of different things that we discussed, right? We really want to know how a particular individual marginal willingness to pay vary with level of Z, okay? With, for example, air pollution. And the problem is that we only see 1 point for each consumer. We don't see the preference of each consumer across different Z. What we only observe is these guys here, is these blue dots. It's 1, okay, for each consumer. There are different blue dots here, right? This is what determine the PZ, but this is coming from different consumers. It's not the same consumer. That's key, okay? So we need multiple points along the bin function, and then we need to measure the slope of each of them. If this is possible, we can get the marginal willingness to pay function and then make statement about valuing non-marginal changes. But let me kind of make the point a bit clearer. This is from a great paper that was published in the JP, the Journal of Political Economy, in 2017. I didn't put it as a required reading, I think, but if you want to read that, it's actually a great paper on hedonic, written by Michael Greenstone. We're going to talk about another paper of his today. But what's going on here? So here we have something similar to what I showed you before, right? So we have air quality here on this axis, and we have house prices here. And look at that. So we have here we have consumer 1, right? And here we have consumer 2, we have supplier 1 and supplier 2, right? So basically what we observe, right, with data is this PZ function, right? This is basically what I showed you before, okay? But again, that showed me 1 point for this consumer here and 1 point for this consumer here, okay? So let's consider an improvement, okay, in air quality, okay, from let's say C1 to C2, okay? Consumer 1 valuation for this change, right? This guy here, we have the whole, let's assume that we know all of that. What that's gonna be is to move from here, right, to here, from P1 to P12. That's the difference, okay? This is consumer 1 valuation of an improvement air quality from C1 to C2, okay? But if we don't look at just consumer 1 preferences, right? We basically, the next point that we see in our hedonic price, right, is this guy here, then the difference actually is much, much larger, right? Because it's not just this difference here, from here to here, it's also the difference between here and here, which is not the same thing. Because this difference from 2 to 3, essentially, is the difference due to the different consumer that we have here, different buyer. And that's the source of the problem. All right? So there are two, right? So this is what I'm saying. So if we had full information on consumer 1, and we can imagine what happened, ask them what happened if you move from here to here, right? Not ask them, if we know that for sure. Don't want to go back to stated preference. The difference in price would be this distance here. Okay? But if we just look at PZ, we assume that actually the difference is all the way up to here. It's from here to here. It's this whole distance here, which is much more than if, let's say, this is the truth. Why is that? Because we don't compare apple with apple. We compare consumer 1 with consumer 2, which are not the same thing. They have different preferences towards the environment. You do not observe with the data this thing here. You just don't observe that, and that's the point. That's the limitation in many cases with the hedonic price method. Okay? You don't observe the same individual in different kind, varying Z, you compare different ones because you can only see transaction data. Okay? Let's take a break. We come back, and the rest is going to be about fun papers and stuff, all right? Pretty much. All right. What's the time now? Let's come back at 5 past 5, all right? Yeah, yeah.
I had a very quick question on the exams actually, because I had a quick look at the past papers.
Yeah.
And there is a lot of references to articles. And I was wondering, so because we don't have the articles during the exam, right?
No, so we're going to do, yeah.
So it needs to be the ones we saw in seminars, or it's all the, like...
So one, I provide the full list in December when we finish about what are examinable articles. And yeah. And if there is a question about specific table or something, I always give the table itself as well.
Because I thought, so I only had a quick glance, but some of the questions were like, what is your research question, what is your empirical method? It was pretty,
No, I know. So it's basically going to be only papers that we discuss either in the seminar or in the lecture.
Okay.
We properly discuss.
Okay.
But I'm going to give you a full list.
Okay.
Yeah?
Thank you.
Hi, Professor. I really don't understand why, if one city is open and the other one doesn't have any movement, why does it change the
Right. So think about two things, right? So if we have an open city, right? We clean one area, the price of the land in this area goes up. Okay?
Yeah.
That's fair enough?
Yeah.
Great. Then what happened? So we said that it's the same, everyone is the same, and we have like a multi-city equilibrium. So we have a small group of people now that get higher utility. No one else is really being affected by that. But because there is an equilibrium here, everyone will share through this equilibrium the increase in utility. But because the increase in utility is going to be divided by everyone, let's say in the United States, you clean one neighborhood, everyone across the United States exactly the same. So then the effect of the utility is going to be tiny compared to a closed city setting. Okay, this is why it's a good approximation compared to a closed city. So it's two small neighborhoods in the United States, right? And you can't move it in between.
Yeah.
You have to stay there. Everyone has the same utility within this geography. Now you clean the dirtier area, right? What happened? The price goes up, utility go up. As I said, there is an equilibrium here that everyone needs to have the same utility. Now you divide this extra utility of this neighborhood by very few people, so now everyone has a meaningful change in their utility. So even those that were not treated are also affected by the treatment, and therefore you don't have a clean identification of how much people actually value, because other things change at the same time. You don't hold everything else constant. So it's coming from, I guess, the size. Right, exactly, and how the additional utility that's being generated is being divided across.
But is it because it's air pollution? If it was any other good, it wouldn't be divided into.
No, it's a point about anything that's kind of like no, it doesn't have to be. It's a point about that it's a closed versus an open one, and then the extra utility is being divided by few or a lot. That's the kind of the intuition.
So like a closed city would be the closest to reality because technically people don't like because we can say that everyone can share the same utility, but if you're in different
No,
areas,
it's just to make the point about I mean if other it's obviously it's an extreme case to make a point. The point is that if basically people that are other people are also treated in a way. If that makes sense. So if it's like a local community and you treat some, think about that. So if we're a small community, you treat some, it's not going to have a spillover on you compared to if you are doing something in New York City and it's a global thing. No one cares. Like this kind of. There's another way to think about it. It's not exactly that, but it's similar.
Like in the document it
You're
said
welcome.
5 is worse than 12. I checked with Mo.
Yeah.
Hi. I had a question about like the closed versus open like city.
Yeah.
Like I didn't really understand the difference.
Yeah. So I know it's not obvious. So.
Yeah.
Right. So think about the following. So we are in the United States. Okay, it's a massive, right?
Yeah.
Place. There is a neighborhood within the city. It's a small city, small neighborhood.
Yeah.
It used to be dirty. We clean that.
Yeah.
Assume that everyone in the United States, when it's an open, everyone has the same utility because people move around. Let's say that's the case.
Yeah.
If we clean this dirty area in this small town in the United States, in this small neighborhood, what happened? The price of land in this area, now it's not dirty anymore, going to go up. Everyone, as I said, that's the point of the equilibrium, everyone should have the same utility across the United States. So this extra utility that they get in this small neighborhood in the United States is going to have to be divided by 320 million people that live in
It's
the
like
United States.
like the influence of like a change in supply on like prices when the prices are set globally.
It's the equivalent on the
Yeah.
urban side, yeah. But it's kind of similar to that, but it's not exactly, but it's similar.
Yeah.
But the point is now that let's say you get an utility of, I'm making it up, 2,
Yeah.
you divide it by 320 million. So basically there is no much of an impact.
Yeah.
Compared to the other case that it's a closed city, and then you basically have 2 small neighborhoods. You clean one. Everyone in this small town now, need to share the extra utility, so you don't divide it by 320 million, you divide it by 50,000, so, you might get something out of it. So then, essentially the control group that you had are also being treated. in a
Yeah.
way, because they also have effect. And then you compare these prices, it's not as clean compared to the other cases that. Yeah, I mean there might be an absolute change in utility overall, but that's kind of. It's a bit provocative. It's a bit extreme case, but just to make the point whether that kind of makes sense to use that.
And like in the second example, because both utility and prices are changing, you can't say that like the change in price fully reflects the, because it's also partly
Exactly.
through.
For utility. So there are two channels here. We want to basically have one channel.
Yeah.
As with the prices, right?
Yeah.
When prices are determined locally,
Yeah.
you know, it affects prices therefore.
And I had one question about this example because like in practice what we will start doing is that we'll like kind of like have a lot of consumers, then we all give them the same like characteristics
yeah.
and then okay.
We're not going to get that.
But it's like
The point is we're not going to get
it's
that.
like a linear regression with like accounting for like difference in characteristics, right?
Well,
like,
we're going to do more than that. I'll show you.
Okay,
Literally,
yeah.
that's what we're going to do now. Yeah.
One question about this graph. So what I understand is that, well, we see only the points where there's market equilibrium,
Yeah,
right?
that's correct.
And the P1, 2, it means that, so that would be like the willingness to pay for consumer one to be of the quality that consumer.
To improve quality, yes. So to move from here, this is better air quality. So this is how much is different from here to here. How much they're willing to pay there for this improvement. But if you infer that, right, from 1 and 2, consumer 1 and 2, you get something completely different.
Yeah.
Because they just have different preferences.
And we don't know number four.
No, number 3 is just a point, right? It's just I want to compare point 1, point 2, and point 3. It's not consumer. But it just kind of shows that this distance here and then. You can read the paper. It's a really good paper actually, which review the whole literature as well. Yeah. Of course.
I have a question about the world agriculture market
Yeah.
because in the local market the price of clean is dropped because of the changes in supply and the price. And there's no change in the price for a global market.
Yeah. So why does it?
Why it's rise?
The price of a dirty land.
Yeah.
The price of the dirty land is basically now it's clean.
Now it's
So
clean.
yeah, because what we did, we basically clean a dirty area. So the price, what it used to be dirty, now goes up, but it's not dirty anymore.
Yeah, and it equals to the land of clean.
They're the same price.
Why? If both of them clean to the same level, it might be.
Or relatively rise, or they are the same.
Well, it depends. If everything else is the same and there is no stigma,
Yeah.
which we're going to talk about on Wednesday, stigma effect, then you should expect to see the price are the same. But it might be that there is stigma like, oh, it used to be
Yeah.
dirty, so I don't want to go anywhere near there. But but yes, but in theory, yeah, it should be the same.
Oh, thank you.
Again, without stigma.
Okay.
And if it's clean to the same level, so basically it produced the same level of output, should be the same. All right. All right, let's go back. Let's go back to hedonic. We did the boring stuff. Now it's the cool stuff, I think. And we might even gonna end up early earlier than 6. Let's see how we do. I know that you had a long day. We'll see. It's very unlikely, but yeah, let's try. All right. Right. That's a crucial point. That's a crucial criticism, or not criticism, that's a crucial point to understand when you estimate this stuff, all right? Because most people, I think, even people that been working on that for a while, don't get that. It's a great paper, by the way. If you're interested in this stuff, go and read the JB paper by Michael Greenstone. Great paper to kind of review the literature around hedonic and kind of make this point more broadly, right? I'm going to talk about kind of a solution for that more on Wednesday when I'm going to talk about one of my papers. There is something in Costa, it's also on the slide here, about how they used to think about doing this kind of stuff. I'm not a big fan of that, so I'm just going to go for it. But if you're interested, it's in the Costa textbook. I'm not going to take it off the slides, actually. I'm not that keen on that. But we're going to talk about it on Wednesday, and I'm going to show you kind of a model that we developed. All right. So before I kind of go into empirical papers and show you how you do things in reality, it's kind of important to remember what do we actually capture here with hedonic, what it actually buys you in terms of what do we actually estimate. So we can think about total economic value as things that are coming from kind of two different things, I guess, use value and non-use value. You can forget about non-use value. Okay, just for example, the existence of a species. If you're interested in biodiversity, you're not going to get that from hedonic. Okay, the only thing that can get you that is standard preference. So if you're interested in this kind of stuff, you don't have much hope with hedonic. So it's only going to be use value. And then within use value, you just need to be aware of that. It doesn't mean that it's not useful. It's just that you need to know what you actually get. And what you're mainly going to get is the actual use, okay? Not optional value, things that you can get, for future use or something like that. You're actually going to get direct and maybe some indirect use. So basically, in terms of air pollution, you're going to get, something like, okay, what kind of improvement you would get in terms of health and things like that. So this is kind of the thing that the value that you will get in the case of air pollution. This is really what you care about, right? Which is very easy for me to work on that. But if you care about some other stuff, for example, around biodiversity, that makes things slightly more complicated, right? Because you might not going to get some of the value that you're interested in. With air pollution, I can't really think about that in this case. So you're kind of good. So again, you need to think about what you're actually trying to get. All right, let's go through papers. Okay, we're going to start with the kind of beginning of the literature to the point that this was actually before the literature was developed, the theory was fully developed. This is kind of an old paper from Restat, a Review of Economic and Statistics, going back to 1967. And let me tell you what they did there. So they infer willingness to pay for clean air using effect of pollution on property prices. Okay, the way that they did that, they got data on 167 census tract of St. Louis in the United States. So basically, census tract is just some kind of a relatively small geographical area in the United States. They don't have data on individual property. They just have it at a more aggregate level, which is fine. It's still kind of relatively small. It's not ideal. And the dependent variable is the median property prices. We can talk about that, or maybe not, whether you should use median or something else. What they had, basically this is what they had on the left-hand side in the regression equation, right? So I hope that you all kind of, by now, whether you're a UConn student or ECC student, you all kind of understand regression pretty well, I hope. So this is the left-hand side, and then what we had on the right-hand side is some controls for the characteristics of housing in census tract. We have data on school quality, so they control for that. Highway accessibility, neighborhood attribute, taxation, and public services. So they control for a bunch of different things. Some of them are related to the picture that I showed you, maybe half an hour ago about the thing that we potentially care about when we go and choose where we want to live, education and things like that, all right? And then the key variable of interest for them, I guess, well, I don't guess, it's what they're interested in, is basically pollution, okay? And they have this kind of index, right, which depends on a few pollutants. And this is the regression that they run here, right? So on the left-hand side, you have the price, median property prices. Here we have the pollution. So the beta coefficient, this is basically what they're trying to estimate. Plus they have a vector of all the different independent variables that they also include in the control and the error term, okay? So this is the results from their study. And this is the coefficient. So this is the beta coefficient, is the standard errors, and it's significant, right? Just to remind you, it's basically this guy here divided by minus the null divided by that. That's going to give you the t-stat, right? And it's clearly significant. You can also calculate the p-value. But what did they found? They found that there is, property price decreased by $245 per unit of this index, okay? Whatever this index actually means. And the question that I have for you before I kind of move forward, what is the problem of running a regression like this one? What are the issues of doing that? Yeah. Absolutely right. So there is no policy here, but everything else is absolutely correct, right? So basically you don't get causal. Evidence here is just correlation, but why? What is the underlying problem here? What are we doing? What did they do wrong? Yeah.
Oh, so just in general, just OBB, so variable bias.
Absolutely. Yeah, so this is kind of the main issue, I guess, that they have here. There are some potential other issues as well. But one of the key issues here, is that what you guys want to say as well? Yeah, it's a multivariable bias, right? But what do we compare here? We compare different census tracts to each other. Some of them have higher level of pollution. Some of them has lower level of pollution. They might going to be very, very different on so many different dimensions, right? Think about different areas in London. I mean, if you want to compare, I don't know, Kensington with some other place that I'm not going to name, which is not as nice as Kensington, right? You might going to get something which is, you don't compare like with like. You don't compare apple with apple. You compare apple with banana. This is not what you want, right? So then they try to do something around that, right? So they're trying to control, but this is only observable. What about the unobservable? So that's kind of the key issue that I hope by now, finally, you all know that at the LSE we're obsessed with causal inference, and that's not going to fly here. Okay, so if any of you are going to run regression like that, I'm going to find you wherever you are, and I'll be very upset. All right? So we're not going to do that. We can do something better. Okay? It's not going to be perfect. Nothing is perfect, or almost nothing is perfect, but we're going to try to do something slightly better. And let's talk about a few other studies that kind of improve on this literature and do something slightly more sophisticated. Going back to what we discussed before, right? Again, the gold standard of causal inference is RCT, right? Randomized control pattern. We might not going to be able to do that here. Actually, I'm going to show you a paper that does something with the housing prices with a field experiment, with an RCT. Today, I'm going to show you that. That's the paper that I added 10 minutes before today's lecture. But in general, we don't have that. So what we're going to use, we don't have an experiment. We're going to have this kind of perfect experiment. We have a quasi-experiment, almost experiment. This is what we're going to try to use in order to overcome the OVB, in order to make sure that we don't get just correlation, we get causal link. So this is a paper, it's a seminal paper in the literature. This is why I use that. It's a bit old still, but it's a great paper by Chan Greenstone, published, don't remember, I think QJE, I don't remember, or AR, one of them. And basically what they're trying to do here is to study home prices, but for this kind of exogenous variation, what they use is the Clean Air Act in the United States, okay? And that's what's gonna create this kind of assignment or almost random assignment into treatment and control group, okay? What happened there in the Clean Air Act? It imposed ceiling on pollution level by county somewhere in the mid-1970s. There are a few amendments after that as well. It's a very great research design. By the way, to the best of my knowledge, this is not the first time that this research design was used in this paper. Everyone thinks that that was the case, but in fact, there is an AR paper by Vernon Henderson, which is a professor in our department at LSE. He's an urban economist, one of the best urban economists in the world. And he has a paper from, I think, 1996 at the AAR, or maybe even before, that does basically that. Okay, so in the footnote of this paper, I think they attribute the research design to Vernon that still teach and still research here. Okay. But basically what happened is that once they imposed this ceiling on pollution, counties that were above the level, this maybe somewhat arbitrary level of pollution, had to cut down pollution. Okay? To different level depends on how far they were, right, from this somewhat arbitrary level. Okay, so high pollution country experience sharp reduction in pollution level relative to low pollution country, and they leave, basically they identify of this variation of how far are you from this threshold that from this legislation. Okay. If I remember correctly, it was the threshold or the legislation were around, I want to think 75 TSP. TSP is total suspendable particle. We're going to talk about particulate matter pollution next week more. I'm going to talk about PM 2.5 next week. This is essentially PM 100. Okay, so it's something that we don't regulate anymore. We used to regulate it until 1997. Okay, so let's kind of see what happened here, okay? Essentially what we're going to have an assignment into treatment and control group based on ex ante, right, pollution level. That's what we're going to get here, okay? And the way we're going to do that, we're going to have before and after, right? We have treated and control group, so we can have a simple diffs and diffs, which I hope you all covered in your econometrics class. Yeah? Today. Fantastic. Thank you, Stephen. All right. So let me show you that, okay? So what you can see here, this is kind of the time series, how it kind of changed over time. You can see that these guys here, right, this is the non-attainment, those that have pollution level above the 75 threshold that I mentioned. Yeah, it is 75, right? And it was a JPE paper, by the way, I think, given how it looks. So 75 here, this is kind of when, I guess, when the legislation took place. And basically, so that's going to be the treatment group, right, just before, and this is the control group. And what you see that after the policy, this kind of gap between them start to kind of close over time, okay? Now, you can look at that in kind of, what happened here in terms of the, in two things. One is basically what I showed you before, which is what happened to pollution concentration over time. So what's the effect of the policy on pollution concentration? This is one thing that you might be interested in, okay? Another way to think about this is potentially the first stage that we're trying to do here. Because what we're trying to do here is not about thinking about pollution reduction, it's actually trying to think about how the house prices how house pricing tell us anything about or something about the willingness to pay, right? So the concentration here is great, but this is not the main goal for us, right? Just to remind you, okay? So the first thing here is still kind of interesting. So we see around, what was that? I don't remember. I think it's like a 10, right? TSP reduction, I guess, in TSP, right? So this is how we see it. It's all very significant, and it seems pretty kind of consistent across the different specification. You just had more control, less control, and things like that. And then, so this is the first stage. This guy here, this is not the two-stage least square. It's an IV. You haven't done IV yet, but you don't need to worry about IV for now. You know what? If you haven't done it, you don't have to worry about it for now. What we have here, actually, this is the reduced form. So this is the effect of the policy, right, on the house prices. And we see that the effect here is around, here in this specification is around 3.6%. Okay, so the improvement, right? Because what happened here, why it's positive? Because now we actually improve air quality, so house prices going up, on average by 3.6%. That's what we have here. There is no IV here. In the paper, they also have IV. I didn't put it here because you haven't taught IV yet, right? You haven't learned IV, so we can do IV like next week. Hopefully you do it by then. But in the paper, they also have IV using this guy here as a first stage, but you can just think about the reduced form. The benefit of just thinking about the reduced form, for those of you that kind of did some econometrics before, is that you don't need to worry about the exclusion restriction because it's not needed for the reduced form effect, right? So that's not needed for these two-stage least square. You need the exclusion restriction as well, and then it will require some more assumption around that. But this is what they found. And again, here, is that perfect? I don't know, right? I mean, these guys here are different, right? They are not the same. Yeah, you have the before and after, but you still live off the kind of distance from the cutoff point of the threshold. But it's definitely a massive improvement to what we had before. So it's not bad. There is some concerns around that, I'm not going to lie, but it's pretty good. Also, what concerned me actually a bit, not too much, but a bit, but I'm very picky here. I mean, it's a great paper. I wish I would have wrote this paper, by the way. So don't get me wrong. But if you really want to be picky here, is that what I don't like is that the coefficient here changed quite a bit between different specifications. So when you kind of add more controls and stuff, that changed, right? So country, data book, covariates, no. And then once you add that, that changed quite a bit. And I wonder what else we can put in that we haven't put in that's going to change this coefficient, right? So I think I mentioned it before in another paper that we did in seminars, that if I kind of add more controls and stuff and the results kind of look very much the same, the point estimate, I feel very, very positive and very kind of like confident about my results. But if I kind of start adding more controls and like things kind of get a bit crazy, it's not crazy, okay? It's still within, there's a reason why it was published in this journal. But if it starts to be a bit off, then I'm like, I don't know, right? It doesn't mean that it's bad. It just means that maybe my empirical strategy is not as good as I might think. By the way, it could be that it's the best you can do, which is fine, right? But you just need to be mindful of that, right? Just going to give you a few tips. I warned you before that I'm going to go off script. I told you that because I feel very strongly about these papers, right? So let's kind of, but let's embrace. This is a great paper. Just kind of being very, very picky. Overall conclusion, what they found, again, if you want to read the full paper, you should read the full paper. It's very easy to read. It's very interesting. They found that 1% increase in pollution lead to 0.25% decline in housing value. The Clean Air Act increased house value by 45 billion in treated counties. And there is some conceptual concerns that we're going to talk about in a second, so I'm not going to go too much into that. Third study, we might actually going to end up earlier. What they do is a bunch of fantastic authors. Janet Carey does a lot of work on air pollution. She's a professor at Princeton. It's also with Reed Walker that also doing some great work on pollution. We're going to study one of his papers next week. One of my favorite papers in this literature. I think that Michael Greenstone is probably also hiding here somewhere. And Lucas Davis, which is a professor at Berkeley, which is also phenomenal. So really good group of authors. And that's published in the AER. And what they did here is they studied the effect of plant opening on housing value. They had a very unique design that I'm going to show you today, which basically based on the proximity of the house from the plant. Okay? And they can actually estimate the decay function of pollution. We were talking about it a few weeks ago. Remember that? I told you that can actually be used, right? Almost the transfer coefficient as an empirical strategy. So we're gonna do that now. Okay? So they had an amazing data set which allowed them to do very different things. They had data on location economic activity of industrial plant. They had data on housing transactions. So this is kind of why this paper made it into this lecture. They also do some other stuff that I'm not going to talk today, talking about birth outcomes. So they look at health. Here, Janet Carey wrote a lot of papers on health, including with Reed Walker. I think she was actually his PhD supervisor at Columbia when she was there. And then also about emission and pollution. Okay, so they have these kind of really great data sets that they can all merge. They all merge together to get a better understanding of what's going on. All right. So this is kind of, I think that I haven't shown you that, but this is kind of the key of their identification strategy. So what's going on here? What they have here is they normalize ambient hazardous air pollution. So they normalize, basically create some kind of an index for hazardous air pollution. And they measure this index as a function from distance to the plant. Okay? So the distance from plant to monitor. And what they found here, this is exceptional level of data, is they found that once we reach around 1 mile away from the plant, the hazardous air pollution kind of go to zero. And they basically estimate this decay function from the specific plants that they have. They have 1,600 plants in the United States. Some of them, by the way, are opening, some of them are closing. It's a really cool paper. And what they actually empirically estimate is like, what the decay function look like from the emission that's coming from plants. And they basically show you here that after 1 mile, poof, it goes away. So they're, again, going to the design, the empirical design, what they're going to try to do, they're going to try to think about treatment and control group in the following way. All the houses that are within 1 mile are going to be treated. By the way, this is something that you can't really see. It's invisible, right? But they will be treated. Households that are just after that, let's say 1.5 mile, they're going to be the control group. So they are very nearby, but look, we didn't know that before. They found out, and now we're going to use them as a control group. Okay? So it's going to be what we call regression discontinuity. But you don't even need to worry about that for now. Basically, the treatment and control group will be determined by this figure here. Yes? Yeah, I always, it doesn't really make sense to me as well. I always want to ask Reed about it, but I haven't, so I don't know. It's not the nice thing about presenting papers that are not mine is that I don't know. When I'm going to present my papers, I'm going to have to actually explain, but yeah. I don't know, but it's something that I always, every year, think about it. Yeah.
Yeah, just wondering on causality, because in this paper and also on the Clean Air Act, if the information isn't there and people
Hold this one. Totally. Can you hold that for like 5 minutes? That's a great point. Great point. We're going to talk about that.
I was thinking about the design of this paper. If the treatment and controls are very close, would it be a spillover effect that will not make causality possible?
Yeah, I don't disagree with that. Yeah, I don't disagree with that. In fact, in a recent paper that we have now, we specifically don't want to put houses that are next to each other because of this concept, because they might interact, there might be other stuff that's going on. There is also uncertainty. I mean, you can estimate that, but there is still uncertainty whether it's really 1 mile, even if it's going below, and kind of make me a bit more suspicious. Anyway, the idea, forget about the practicality, is nice. All right. So that's what they do. Okay. And this is what they kind of found. There is more stuff there than that. But basically, what they found is that if you live, let's say, 0 to 0.5 miles, your house price is on average around 2.2 to 3% lower than similar houses, basically, which is 1 to 2 miles or something like that. I think, by the way, going back to your point, they had most likely, I don't remember, it's been a few years since I read it. They have a robustness check that they use control houses that are further away, and it's the same. I mean, if they haven't done it, they should have done that. Yeah.
I was also wondering if can there be very causal studies about air quality, because air quality is such a spatial variable that also because wind or climate contaminates air control and treatment.
Yeah, so that's what we're going to do next week. Trust me, I have a lot to talk about. I'm going to try to convince you that with my papers that it actually works, to a certain degree. Yeah.
How do they take apart the fact from the air pollution and the fact that these power plants are just obviously, like if you're close to a power plant, you can see it, and I assume that would also increase.
This is why they have here. So the 0.5 to 1 mile, they think that it's sufficiently far. Yeah, exactly. So this is the point that they make in the paper. But that's a great point, yeah.
So they're kind of assuming there's like no other significant difference between the ones that are like 0.5 to 1 miles to the ones that are farther away.
Yeah, because they say like, look, this decay function in pollution was yeah. Again, as I said before, this is why it's called quasi-experiment, right? I warned you, nothing is perfect, right? It's getting, it's look, compared to where we were, like with here, come on, like, this is better, right? We see, we have progress, and we count on you guys to, in your dissertation or extended essay, to, you know, give us the new thing, all right? So that's what I'm aiming for. I'm joking. I mean, great, but don't feel the pressure. But for the PhD students in the crowd, absolutely, we expect you to do that. Yes.
So to what extent do you have to be careful for like reverse causality in those cases? Because like if you already have like a bad neighborhood, then the like land prices they are cheaper, and that might be like more attractive to open an energy plant there. So then you kind of have like instead of like the power plant negatively affecting house prices, you have like the reverse causality.
Yeah, so look, so when we talked about, now that's a great point about reverse causality. Actually, with air pollution, we have a lot of reverse causality. We mentioned before, when we talked about this paper, we said about OVB, but reverse causality is another big issue. The third one is measurement error as well, because we don't measure pollution perfectly, for sure. The only thing that gets you out of trouble with these two things that you mentioned is actually an IV. So that's what we're going to do next week, right? And so that's why sometimes the panel stuff not going to work. Well, it's going to work, but it's not going to be perfect, right? But I'm going to spend more time on it next week. But that's a great point. But even here, going in the wrong direction. I mean, even here, they also in Chang Wisdom, they also use. I mean, also here, but they use it in with an IV. I just didn't cover that as well. But when you do that, you have other things that you need to worry about. Again, we're going to spend more time on IV and stuff next week. But yeah, that's the point. Anyway, so this is kind of what I want to say about that. And then, wow, fantastic timing. And then what I want to ask you, like, okay, this is all great, but what are the limitations? And you mentioned already quite a lot of limitations. I was hoping to have a discussion right now. But one of the things that you mentioned is about information, right? And you said, like, hold on, do people even know about it? And if people are not aware of that, how do we expect to see any change in prices? Because going back to the beginning of this lecture, we were talking about me looking for property, right? Which is not that exciting, I know, sorry. But, you know, at the end of the day, I need this information in order to make a decision. If I don't have this information, that should not be reflected in the price, right? And that's a great criticism. One of the biggest criticism, actually, of hedonic pricing. So because I have some paper on hedonic, so let me tell you what's the answer to that. So a few answers. This is kind of the way that I answer this question in a seminar, in a research seminar. So one, if there is no information at all, then I shouldn't see any effect here. If I see an effect, it's probably the case that there is some imperfect information. Therefore, my estimate, maybe not causal, not perfect, but it's a lower bound estimate. So this is one thing. Maybe this information is not known by everyone, but I guess for that to move here, it's known by sufficient number of people that we get a lower bound estimate. Lower bound estimate, you know, people say, oh, that's okay, it's a lower bound estimate. No, it's not what we want. What we really want is the actual causal impact, but it's probably better than, you know, if we have an upper bound estimate in this setting, not in all settings. Okay? So this is the first comment that I have. The second comment that I have, that especially in my paper, I'm going to show you on Wednesday, that I can show you a channel how I know that people got the information. Because I'll show you that on Wednesday. So I know that people during the house search, during the buying process, they receive information on the specific thing that I'm interested in. Written information. Whether they decide to read it or not, I don't know. I can't put a camera on every single person to see whether they actually read and also do a test for them to see if they understand. but I know that they received the information. That's the second. Yeah.
Yeah, so one of the paper was on the 70s.
No. I totally agree with you. This kind of going back to my first point. But yeah, I agree with you. Right? Look, when you go now, but information is key. This is exactly where I was wanting to go here. But before I kind of show you more on that, look, if you go now and you want to find a place to live, right? So you go on one of those Zoopla or, whatever, you like it? Okay, so we can put a postcode and let's go to the most expensive house. I like doing this thing, right? What I can't afford. So let's kind of look at things that this... everyone get excited. No, not recommended. Highest price. Let's go for that. All right, 18 million. Sounds good to me. All right, so we can live there in Hampstead. 6 beds. So let's look at what information we actually get, okay? And that's going to link it to the... if anyone has 18 million and is on the market, looks like a nice place. But what do you get? You get lots of information. You get obviously the price, right? At least the guide price, what we have here. You have information about EPC rating, right? Energy. You have 5 reception, 4 baths, 6 bedrooms. Lots of cool stuff. What else? What do we have? The thing that we're interested in, right? So how far is the tube? So it's very near to Hampstead Tube Station. You can see the map. It's also next to the Heath, so that's great. I told you that schools are very important, so this is kind of the thing that people are looking for. Obviously, I'm just making a joke. People with 18 million, I don't know what they care about. I have no idea. But maybe one day, I don't know. But, this is kind of what most people are interested in. But it's kind of very interesting, right? So also, look, all these things, by the way, when I started teaching here in like 2016, they were not here. It's because there is a demand for that now. So this is 0.1 miles to the nearest EV charger. These things that they keep adding this stuff because people are interested in this stuff, all right? Yeah, maybe I should have gone to the lowest price or something like that. And obviously you can get the floor plan and all this kind of different, all this kind of different thing that you want to know. Anyway, the point that I'm trying to make is all this information is really available now to a much better degree than what we had before. You can do the street view and all this kind of different stuff. Information is key. And what I keep wanting to see on this platform, guess what? I can't hear you. Thank you. Right. But my co-author is also interested in this stuff. We're going to study our paper together next week. But today, I just sent him on WhatsApp this thing with the new slide that I created. So my co-author is Rob Metcalf. He's a professor at Columbia University, New York. And basically what he did with a bunch of fantastic co-authors, including Matt Kahn, which is urban economist at USC, and Sebastian with MIT, and I think Daryl is in Redfin, which I explain what it is. They try to understand what happened in the housing market when they basically add something about flood. I told you it's not going to be only about air pollution. It's about flood risk, okay? And it's it's really a great paper. It's not published yet. It's a revised and resubmit an R&R at the American Economic Review. There is the latest version online. It's pretty much, it's not going to be changed dramatically from the reviews that they got. So it's good. And there is an NBR working paper as well, which is very similar to the ongoing, the recent version that they have. So let me tell you what they did. Okay, so they did a field experiment. Can you imagine? They did an RCT. Let me tell you what they did. So they cooperate with Redfin. It's kind of the US Zoopla kind of thing. Okay, so this is kind of what's going on here. It's a US real estate platform. So when I was in the US, I always go on Zoopla to see the places that I can afford in California. 70.5 million users were randomly assigned to receive or not to receive flood risk information. So they were able to do an RCT together with Redfin with 75 million users, right? Some of them got information about floods at random, some of them did not. Right? Beautiful. The information that was shown is property level flood score from 1 to 10. 1 is very low risk, 10 is very high risk. And also 30-year flood probability. Okay, so this is kind of, essentially that's the treatment. Again, we don't need to worry about the quasi stuff, all these things before comparing treatment and control group. Okay, that's the beauty here, easy. Importantly, seller and the algorithms were blind to the treatment. So seller did not get this information, and also the algorithm did not know this information such that you would change, for example, the order in which you see houses on the market. So these things are crucial, okay? Approximately, we're talking about 400 million property views during the experiment. Okay, so large scale stuff. All right. What they're trying to do, I love this paper. Rob sent it to me for comments. I wrote to him, no comments, great paper. Test whether providing new news about flood risk change search, bidding, and purchase decisions. This is what they found, okay? So kind of, broadly speaking, you can put it in 3 different brackets in terms of the main findings. It's a long paper, and there's lots to it, but I'm trying to summarize everything. So what they found, first one about search. Individuals who randomly received the flood risk information were more inclined to search and browse properties with lower flood risk compared to the control group. Okay, so those that got information decided to kind of look more into those type of properties. They have also in the paper they have this kind of like heterogeneity, so kind of compare different areas depends on flood. Some of the results are coming from certain areas, which I think if I remember correctly, is that it's potentially more. I don't know if it's surprising or not, but it's actually like not the obvious places that you know it's like rough. There is a big flood risk. It's actually places that are less obvious, which is I guess it's like. It's not that actually surprising, but it's kind of a nice result to find. Right. Among those who initially searched for home with high flood risk, the treatment led to a 12% reduction in the flood risk of their search home after 2 months. Treated individuals were willing to trade off certain property characteristics, such as neighborhood amenities, bike and walkability, which is a big thing in the United States. And their consideration set of properties become more spatially concentrated. However, treated individuals did not adjust the price, size, number of bedrooms, or number of bathrooms of their search. So people didn't say like, look, you know what, I don't want to have a 2-bedroom rather than a 3 bedrooms. They did not. They were not willing to trade that, but they were willing to trade kind of neighborhood amenities, specifically things around walkability and things like that. Right. So that's kind of an interesting result as well. In terms of kind of major findings is around bidding. So they found that randomized flood risk information did not significantly change the overall probability of touring a property to do a viewing, placing an offer, or closing a bid through Redfin. Okay, so there is no extensive margin behavior here. But it did have an effect on the bidding behavior at the intensive margin. What do I mean by that? Well, treated individuals who were initially browsing high flood risk properties were more likely to make offer on properties with approximately 57% lower flood scores compared to the control counterparts. Okay? So there is kind of shift to where they kind of put the offer. And they also find that all treated consumers, irrespective of their baseline risk, make an offer quicker than the control group. By the way, speed on the market is crucial as well. Okay, it's important. And this is larger for those that are searching for high flood risk home at baseline. Okay, so we're talking about 7% reduction. And then finally, in terms of prices, I'm not going to get to you in just a second. They found that when all Redfin looking at property are treated, in comparison to no Redfin user treated for the property, so kind of in the absence of this experiment, property prices dropped by almost $7,000, around almost 2%, for homes with high flood risk across the United States. Okay, there's some assumption going on in here, but overall, that's what they found. The reason why I wanted to put this paper in, first of all, I think it's like a really cool paper that they managed to do this kind of RCT with so many people and kind of like see what happened when they incorporate, basically my wish to incorporate more stuff in here, okay? And it's kind of relate to the point that you made about information, because how environmental information can actually have an impact on the property market. So I'm kind of done, but there are two questions here, so I'm going to take them. I don't know who was first, but I assume that you were first. Sorry, you mean between the first bullet point and the second bullet points? Right, so randomized flood risk information did not significantly change overall probability of touring a property, placing an offer, or closing a bid through Redfin. Well, it changed behavior, but depends on what kind of behavior. That's the point. So because there are many things that they can check. One is like whether you go and tour, whether you put the bid in, what the bid that you put in, how long it takes you to put the bid in, how long it takes for completion. There are lots of different elements here. So what they found is, or another thing of behavior, like what are you willing to trade with, right? So for example, I told you they're willing to trade neighborhood amenities with lower flood risk, but they're not willing to trade number of beds. So depends on how you think about behavior. So there are different margins of behavioral change here that they check. It's a lot actually. Yeah. No, they actually look at the difference between the offer price and the purchase price. Yeah, they don't have rent. To the best of my knowledge, they don't have. No, that's a great point. I mean, I think that in this case, I think you're probably more interested in the sell price of like being owner rather than rental, because if there is a flood, you're going to get somewhere else. You're not going to be affected to the same level as if you own the property, one thing. The other thing that we don't discuss here is insurance. In general, I haven't discussed that today as well. You can think about why do I care that much because I have an insurance? But it's not that simple, because actually insurance will change, the premium will change based on both risk and definitely realization of a flood. So that would be captured here. But I guess that in this setting, I would prefer asset price rather than rental price. But yeah, that's a good point. Yeah.
Yeah, on that side about insurance, I was just curious because I'm not sure, like, how could that knowledge on maybe my insurance will be more expensive? Like, at what point do people know about it? Because I know, like, insurance companies are starting to use, like, climate risk for their insurance prices, but I don't know if, like, people do know or when do they find out about that?
No, right. So a few things to say about it. So first of all, when you, again, and it changed by location, right? So I can tell you definitely that when you buy a place, you definitely check what is the insurance. And if I remember correctly, one of the forms that you have to get here, there is a question whether there was a change in premium in the last 5 years or something like that. And if it's not you, that your solicitor, your lawyer, will do some checks around that. So this is in the UK. Another example, which is I think more, and definitely there is a lot of question around flood risk, etc., that you as a seller will have to disclose to the buyer. This is the legislation that happened, I think, in 2011. That the seller have to provide this information back to the buyer. And one of the questions there, I can show that next week, or even on Wednesday, is around flood. The other point about, in general, knowing, I mean, look, I was in Santa Barbara last year, and lots of exciting conversation with faculty and stuff is around insurance on the home, because they have lots of fire risk in this area. So what's the premium? How much is that high? Is it even insurable? Because lots of, I don't know if you know, but lots of kind of companies, insurance companies decided to leave California because of certain legislation, things like that. So that's something that people in specific areas that on average have higher risk, they are fully aware of that, and they also I don't know say fully aware, but like somewhat aware about that. And I think that it's fair to assume that that's going into consideration when you make an offer on health. If you can insure it or not, and what's the premium. Because that can be a significant amount. So yeah, there is a lot of literature around insurance, obviously, with this stuff, and that's kind of when we have a job market candidate that's kind of trying to get a job here, and they present a paper with don't tell anyone with a DONIC and stuff. I always ask them, what about insurance market? How would that affect your results? Just to see how they react. Go ahead. Yeah, they just kind of like did kind of almost like an exercise in basically saying like, if we provide, because they didn't provide information to everyone, right? But if we would have do that for everyone, what would be the results in terms of the average price of the property um, for home with a high flood risk compared to low flood risk, and that would amount for almost 7,000. So going from like 1 to 100, and everyone were treated compared to everyone before and after kind of thing, but everything else constant. That's possible, but that's true for both, for the control and treatment group. So this is why the RCT deals with that. So it's basically, I totally agree, they should, as I mentioned before, but how this information give you more. And that, by the way, might explain some of the findings. So it may be kind of like time on the market and all these kind of different things, but maybe it doesn't change completely, especially in areas when we already know there is floods, the price that much. Maybe it reveals some information because people were just like not as thorough as they should in areas that they didn't know there is flood issues. For example, in Santa Barbara or in California, everyone aware of fires and they know it's a big thing. But maybe in other parts, which is also important, but people are just not as aware. This is where they find most of the results for the flood. All right. I think it's perfect time to finish it. I can claim that I finished before time because I'm 1 minute ahead of time. See you guys on Wednesday.
Like,
GDP